Sources of error and how to determine our uncertainty. So we've actually talked quite well across the course of the year with different bits of kit about how we can think about the precision of the tool. The strongest example is shown here. Someone's obviously been measuring anthropometry of the arm, flex bicep and length of the arm, and they've come up with an uncertainty that's quite generous, because we know that most tape measures are actually really small. Their units are really small, like 0.1 centimetres or 2 millimetres. However, we know that there are other things that contribute to the errors that we acquire. So for example, in this case, human error considered, maybe the participant is shifting around, maybe the tape measure's not straight because you're having to eyeball it. Maybe there's also things like your ability to read the tape measure precisely. So usually the tool's precision is nowhere near close to the source of error itself. And another good example is a stopwatch. A stopwatch has a really, really high degree of precision. It's like 0.0001 seconds, something like that. But we know that human reaction time is closer to 0.4, maybe even bigger in some people. So we want to actually be probably closer to plus minus 0.5 seconds. That would be appropriate for a stopwatch. And you justify this. You need to talk about all this in your work. So let's have a look. This is one way you can do it. You just factor in all the things that you've considered and you come up with a rough estimation. But there is a more accurate way that you can actually look at an individual person's uncertainty. So let's have a look. I'm going to insert a column to the right. And what I'm going to do here is call that column uncertainty. And I'm going to use this method that is here, and this is on slide 33. It's how to calculate using the uncertainty formula. So let me just go back to my spreadsheet. What we're going to do then is we're going to do equal sum, and we're going to take our biggest value that you've got to identify and minus our smallest value. You close the bracket and you divide by 3 because that's the number of pieces of data in this set. You press enter. You cannot drag this one down because everybody's got a different value, largest and smallest in different places. So if I just go to this one here, equal sum, we've got our biggest one here and we subtract our smallest one here. It's different placement. So this person's uncertainty is actually higher. So what we're really looking at is variance. We're looking at variance in the data set to determine the uncertainty, rather than just saying this person's, an individual reading gone wrong using this method here. That's this, but actually we can calculate uncertainty in this way. So you've got two options there. I think you can choose either one, but this is obviously going to be more specific, especially when you've only got 3 readings, or maybe even 2 or 4. This is not applicable here because we can calculate standard deviation, which is way more precise. So this method is for using 4 or fewer pieces of data to calculate a unit uncertainty, and this is what we can use our error bars for. Please make sure that you actually talk about this and you write what you're doing and you show what you're doing in your analysis document. That's really important.